Hello and welcome to the fifth part of this series of animation nodes tutorials in Blender 2.8, where we will use the recently added sound spectrum node to animate some stuff. Making the objects move is the easy first part, and there are already many tutorials out there on how to do this kind of thing with animation nodes. But I wanted to do something different that I haven't seen before, something a bit more advanced. So after several failed attempts, I found a way to make those peak level markers, and I will show you how in the second half of this video. At the end, I will also quickly show you how I made the colors of those pins change. In a previous video, the third one in this series, I showed an animation at the end and several people asked how to do that color change. It was done in a similar way, so if you were wondering, stay tuned. By the way, the previous 4 videos are linked below for you to enjoy. Now let's get started. Here I am in Blender 2.8. This is still beta. I delete everything and first I'm going to create a new cube. Go to edit mode, scale it with Shift C and make this pin shape. Control P, give it a little bit of a bevel, just to make it look more interesting. And I will call this pin. Now I will open animation nodes, create a new node tree. Over here, switch off always, switch on these 3 options. And now I will use an object instancer to create more of these pins. So just I drop that in. How many pins do I want? Well, I just add an integer input node. Let's say we want 40 pins and plug that in here. Over here, animation nodes has created 40 pins. So I can close this and hide my original pin. Here we have 40 pins all in the same location, and I'm going to place them along the x-axis inside of a loop. So I need a new loop and I need to invoke this loop. My first iterator is going to be an object list. Call it pins, and I can plug my pins in here. What do I want to do with those pins? I want to place them along the x-axis, so I need an object transform output for the location. Okay, I want to place those pins, and I want to use the index on the x-axis to place them. Of course, this is now too far apart, so I need a number math set to multiply. I can use this factor now for spacing them, and then I just duplicate this, set it to add, and now move them over to the left looking from front view. I will have to place them here somewhere so that they're in the middle. Okay, that's the X location for the pins done. Now the Y location, this is where we need the music to make a move up and down. So first up, let me just save this file to a new blend file. And I hit this little plus icon, go to video editing right here. I am at the first frame, which is good. I can hit Shift A and plug in my sound that I downloaded from the YouTube library. Okay, this is the music. Now let's go back to our node tree. We need a sound from sequence node, and we can just eyedropper that in. That's the sound file that I just added. In order to get some information out of this sound file, I need a sound spectrum node. Plug the sound in here. And the output here is a list of floats telling me the volume, the amplitude of the sound inside of a frequency slot. And here I can set the amount of frequency slots, and I'm just going to use the same 40 slots for my 40 pins. And in order for this to work, I also have to plug in the animation time info frame right here. Now to use the value coming out of here, I also, by the way, set the amplitude to 1. So the output here is a float between 0 and 1. Okay, now I want to use the amplitude, so I need a float list in my loop. I'm gonna call that spectrum. And plug it into my loop. Okay. I'm going to use this spectrum value to change the C location. And when I plug that in and play the music, we already have movement, but it's not really very strong. So I pipe it through a multiply node, set that to 5, and use this math node to move all the pins just below my 0 level on the C axis here. So that when I add a ground plane later at the C height 0, they're completely not visible if they're not moving, and they come through when they're moving. So let's see what that looks like. Okay, so that's the easy part done. We're moving some pins on the C axis according to our music. Instead of moving them, we could also scale them on the C axis or do something else. This is everything we need to do to get that effect. Now comes the tricky part. I want to make those peak level markers. Whenever we have a peak, we want the marker visible and we want it to stay there for a few frames. First, I'm going to need an object for the marker. I'm just going to use an icosphere, add 3 subdivisions, go to edit mode, scale it down to something like this. Okay. Move it to this collection because I accidentally created it in the animation nodes collection. Call it marker and hide it. I need 40 markers, so with the same integer input here, I set it to my marker. I need to modify their location in my loop, so I need another iterator. Object list markers and plug my 40 markers in here so I can do something with them inside of the loop. First thing I need to do, of course, is I need to place them in the same X locations as the pins. So object transform output, the marker to the same X location, so I need a combine vector X right here. Now all markers are where the pins are. I'm going to need more space here. Now for placing the markers on the C axis. The problem is we have to have some sort of memory. So whenever there's a new peak value, we want to store that peak value for that frequency slot, and we want to save that information in a variable. And I tried to figure out how to create global or static variables in animation nodes, and my first attempt was to just create a list of floats and then fill that list with values and then store the peak values inside of that list. But the problem with this is every time the frame changes, animation nodes executes this entire node tree. So every new frame creates a new list. This is not really a memory over time that I can use. And I finally figured out how to do it by realizing that I can create a sort of global variables or memories inside of Blender. Each of these objects here is a global memory of sorts. And the thing that I finally did to store information is this. I created a mesh grid, and in the grid options here, I took 40 subdivisions for my 40 pins and just 2 subdivisions on the y-axis. Then scale that up so that it sort of fits the size of my pins. And when I go to edit mode, now I can actually delete those row of vertices in the back. And this row of vertices is like a memory I can use. Let me just move the vertices on the Y so that they're in the front here. Looking at them from the front, I can see that I need to move my pins on the x-axis a little, like so that things are matching up. And now you can see I have a vertex in this grid, one vertex for each pin. And each vertex has an X, a Y, and a Z, and I will use the Z value to remember the peaks. So I just call this memory. And of course my subprogram needs access to this memory object as a new parameter object. And here I just use my memory object. So now I can access it inside of my loop. Okay, now this is a mesh object, so I just use a mesh object input. This is the grid. And the output here gives me a vertex locations list, a list of vectors. Which one of those do I want inside of my loop? Well, I want, for the first pin, I want the first vertex. So I go to list, get element. This is the list, and the index is the vertex that I need. Now here I have a single vector. I'm going to separate this vector into its X, Y, and Z component. Back here I will combine the vector together X, Y, and the Z is going to be my memory. Last thing, I have to place this vector back into this list. List set element. So this vertex list at the same index that I had here will get a new object, a new element, this vector. And finally, out of this new list, I will have to create a new mesh. So mesh object output. And also I have to do a mesh combine mesh. I can put a list of vertices in here that gives me a mesh, and the output is going to be the same object that we started with. So this one. Here animation node says object is not in object mode or is no mesh object. I'm in edit mode up here, and as soon as I leave edit mode, go back, we can see that the error message here disappears. Oh, I forgot to switch this on. And now if I hit the play button, nothing really happens yet. We have to do something with the C value of our vector. Maybe bring this down a little because at some point there's just too many lines. And what do we want to do with the C value? The C value is going to store the information that comes in here on the spectrum. And whenever the spectrum is larger than the stored value, we have to store a new value. And if it isn't, then we keep the value. And we can do that with a compare node. So Control A, compare. What do we want to compare? We want to compare the spectrum value. And if that spectrum value is greater than the stored C value, then we use the spectrum value. So this thing. Okay. And if it isn't greater, then we use the original value. And this is going to be our new C output. Now if I go back and play, you can see that the vertices here, the orange dots, they store the peak values. And they stay there. Okay? So that solves that problem. Next, we're going to move our marker objects, those icospheres, to those locations. Over here we already moved them on the x-axis, and we're gonna use this C output here, the stored peak output, to change the C location of the marker object. So we take this and plug it in here. Now they move up to that location. But since we multiplied the C value by 5, we also have to do that here. So we need a new number, math, multiply by 5. Take this C location, multiply it by 5, and this is going to be our C location. Okay. Let's see what that looks like. If I find a peak value like this one, I might also have to add a math add to move the C location up and down a little. Okay. Now in order to see what is actually happening, since those values never come down again, I could, for example, change something down here, saying that if it's larger than the stored value, then we get a new value. But what if I add a new number math node right in here, and I say I don't just keep the stored value, I subtract like 0.05 from it, which means that those markers, dots, will not stay at the peak level, they will move downwards slowly. So this is what we get then. And if I remove this math node, we get the peaks staying at the peak level for that frequency slot. Now this node tree here is becoming a bit complicated, but there's more that we have to add to it. Because what I actually want is I want the markers to stay where the peak was for a few frames and then disappear. So we need to find a way to store the time information when that peak was reached, and then a few frames later use the information to remove the marker. Down here we've used the C value of those vertices here to store the information of the spectrum node. Okay? But that vector here also has an X and a Y that we can use to store some other information. I'm going to use the Y information to store the time when the peak was reached. And the way I do that is this output here tells me when a peak was reached. So I just use another switch node. And if there is a new peak, I will set the Y value to 1. And if there isn't a new peak, I keep the Y value that I stored in the vector here. And this is going to be my new Y value. So whenever there's a peak, the Y value will be 1. So this vertex moves back to the 1 location on the Y-axis. And in order to have it move back forward, I can't just use the stored Y value. I need to use a number math and subtract a little bit from it. And now let's see what that looks like. If I go back here and press play, you can see whenever there's a peak, the vertex moves back here, Y value of 1. And then when there's no peak, they just simply move forward. Now we can limit this forward movement by plugging in another math node here, setting it to a maximum of 0, so that they move to 1, and then slowly move down to 0 again, but they never move past 0. Okay? And that's what that looks like. And now I will use this information to determine if the peak marker should be visible or not. And how do I do that? Well, I need another compare node. So I will compare if the output here is greater than 0, meaning if the little vertex orange dot is in the back here, then I need another switch. The output should be the C value calculated here. Okay, and otherwise the C value should be 0, and this is going to be my new C value for the combined vector node and for the location of the marker. Okay, let's play this again. And there you have it. The markers are visible as long as the vertices are on a Y location that's greater than 0. Okay, we can make them stay visible longer by making those markers move forward more slowly, like so. Now they move slower and the markers are visible longer. Or we can make them visible a lot shorter by making the vertices move faster. We could also use this information, the time information, to scale the markers or do something fancy with them. You know, you can be creative with this. This is the basic setup that you need to accomplish the effect that I was looking for. Now all that's left is basically to create some sort of stage and lighting and materials, and I want to do that next. So first I will create a ground plane, scale it up. I will also make sure that those markers are not visible when there is no peak, so I can use this node here to move them below my ground plane. Okay, now I don't have pins visible or markers visible. Okay, Now I will assign some materials. The marker is supposed to be a emission, white emission 5. The world, we're just going to make black. And the pin also needs a new material, also set to emission. And here we're going to play with the colors then. Okay, as usual, glow, bloom, effect. Okay, so that's what that looks like. Now let me split the screen here quick. Add a camera. Place the camera. Go to camera view. Okay. Move back, move up. So we're looking at our animation like this. Okay, we're gonna have to move up a little more. Maybe give this ground plane also a material. Make it dark. Switch on screen space reflections so that we get some cool looking reflections down here. Change the roughness. Okay, this bloom effect is always way too much. Take down the intensity a little, like so. I actually want those markers to be visible longer, so I turn down this value. The vertices move slower. Okay. One other thing I want to do is, see down here we have all those markers, and those are not really peaks. I think I want to add some sort of threshold for those peaks. I only want a peak to count as a peak if the spectrum value coming in is larger than, let's say, 0.5 or 0.2. So I have to add some more things here. Okay, first let me move all of this over a little. And then add another compare node. And only if this output is greater than, let's say, 0.2, then we actually use it. And otherwise we just keep the value at 0. Okay. Now what we should get is only those peak markers only if the value is actually larger than 0.2. Let's make it 0.3. So we only get peak markers in the higher regions. For the final render, I also gave this ground plane a bit of a texture by simply adding a checker texture, plugging that into the color, and also adding a couple of point lamps, one here and one here. Maybe make one blue, and this one, I don't know, let's make it red. Okay, also have to make sort of a stage. Can bevel this corner or just leave it. I also want to switch off shadows here so that those pins don't create shadows from the lights. Okay, and now finally, the colors. Okay, so those pins have this material attached to them, and changing the colors of those pins has nothing to do with animation nodes. It's all done in the material nodes. And what I did is I just took an input geometry, and here I have the position that I can convert and separate the position into the X, Y, and Z. Now I can use the C value through a color ramp going from green to red as the factor, and this is going to be the color. And here we have it. The higher the C value, the redder the color of the emission shader is going to be. I want to go to somewhere where there's a high peak value, like right here. And now they're all completely red. So I might want to add a converter math in here. Multiply this. And then change the multiply value factor here to stretch out this color ramp a little, so that we have green at the bottom and red only at the very top. Of course, you can do other color ramps, or you can tweak the color ramp so you have more in the green area and then a little bit in the orange, and only the high peaks in the red. Whatever you want to do here, that's up to you. Okay guys, that's it. All you have to do is maybe play with your lights or your textures and camera movements and whatever. You can render out the animation. Let me go back to the animation nodes, to our node 3. Let me just recap quickly. First, we create 4D pins and 4D markers. We create a sound spectrum from our music. Use the frame to drive the sound spectrum node. And the sound spectrum node also gives us 4D spectrum slots with an amplitude between 0 and 1 because of this setting. And we pipe all that into our loop where we do all the work. We use the index to position the pins on the x-axis, and we also position the markers on the x-axis with the same location here. And we use the spectrum coming in from the audio to move the pins on the z-axis. Okay, so that's the easy part. Up here is the pins, and then all this down here is just to store some information about the peaks inside of another object, actually inside of the vertices of another object. So here we have the object. We rip that apart into its vertices. This is a list of vertices. Then we take the vertex apart into its X, Y, and Z location. We store the peak levels inside of the Z location. We store the time information when the peak was reached inside of the Y location. Back here, we combine a vector again, place it in the list, create a mesh out of this list, and put that mesh back into our object so that we have a sort of a memory to remember the things over time. And that Z location that we came up with down here, we use to move the markers on the Z-axis. Okay, I hope this makes sense. If there is any other way to store information over time other than an object inside of Blender, please let me know, because I couldn't find anything on that. Also, if my solution is way too complicated for what I want to achieve, then also please tell me. Okay guys, let me know if you like this video series so far. Subscribe if you haven't already, and check out my channel for more Blender tutorials. Thanks for watching, have a good day, see you next time.